Hello guys, welcome to my channel, and today we are going to design a parking lot in object-oriented manner. As usual, let's first think about the objects that are related to this scenario. When we think about a parking lot, then the first thing that is obvious that comes in our mind is parking lot itself. Okay. And we are going to make a object out of this. It will be a class, and this will have a list of floors. Okay, this is one parking lot will have lots of floors. As a single parking lot can have multiple floors, we are keeping it inside a list. And let's go further inside the floors. According to our design, we are going to have lists of parking spaces and also a number of available spaces. My handwriting is so nice, hope you guys can understand it. And as this is an integer, we don't need to make a class out of it, but this is a class. And let's consider what defines a parking space. One parking lot will have multiple floors, one floor will have multiple parking spaces, and the parking space will have a space allocator and also a enum of size. This enum size can be small, medium or large depending upon its size, so that these sizes, its dimension can be compared with the vehicle that is to be put inside of it. This is the enum. Now this space allocator, let's consider what is a space allocator. It will have a vehicle inside it and also the start time, so that we can calculate the duration for which the vehicle was parked in this space. And space allocator will also have a field of vehicle class. We will define it shortly. Let's first analyze this diagram that we have built till now. A parking lot will have multiple floors. A floor will have multiple parking spaces with number of available spaces value also. And a parking space will have a space allocator class and also its size enumerator, which can be small, medium or large. And the space allocator will be responsible to hold the data of vehicle that is inside of it and also this start time. We could have easily removed this space allocator, but for the proper design perspective, we are making it, normalizing this outside the parking space class. Now let's see what the vehicle class will look like. Now we will have a vehicle which will be a abstract class. I'll give the reason why we are making it abstract shortly. And this vehicle will have parking space, a class inside of it that we constructed in the previous slide that we had. It will also, parking space will have a space allocator which will contain the vehicle, and vehicle also should know in which parking space it is been parked. That's why we are having a field of parking space hold inside the vehicle, and also the number plate of it and also its size. Size is as usual a enum of small, medium or large. Now this vehicle will be extended by three other classes. One is car, other is truck, and other is bike. Now these three classes will be inheriting from this vehicle class all these properties, but they will have the size of, it will have the size of medium, truck will have the size of large, and bike will have the size of small. Hope it makes sense. And in this manner we are going to construct the parking lot, and we will also have the methods to park the vehicle inside any parking space that is available. The parking lot class will be responsible to check all these floors and all the parking spaces that is available and park it. If none of them are available, then it will throw out a error and it will also be responsible to remove the vehicle outside the parking lot. Let's see the code example of it. So guys, this is the code example, and if you want to peek inside it, the code is placed in GitHub in the description section. So now, so you can see that this is the parking lot class, and it has the list of floors, and it also has the method to park the vehicle by passing the vehicle, and also remove the vehicle by giving the floor ID and parking space ID. I will go inside this in a little while. Let's go inside the floor class, and as you can see that the floor has a ID and list of parking spaces, because one floor will have multiple parking spaces, and it also has the number of spaces available integer value onto it, because we want to make it optimized performant, because we don't want to check for each and every parking spaces if it is available or not. If the number of spaces is contained in the class, then we don't have to go inside each and every parking spaces. We can get if all the parking spaces is occupied or not by this simple integer value. Let's go inside the one floor will have lots of parking spaces. Let's go inside the parking space, and a parking space will have a ID as usual, and also the space allocator like we discussed in the slide, and it also has the size enum. And let's see what is the enumeration. It is nothing but large, medium and small values. Let's go inside the space allocator. Now the space allocator will contain a vehicle. If it is parked inside that parking space, then its data will be populated in here. And also we have the start time variable, which will calculate the start time of when the vehicle was parked. It is an instant. It's like date time of Java, but little more elegant. And we are having the getter and setter for all these fields, and this is the empty constructor. And let's go back to the parking space, and the parking space also has the constructor of ID. We need to pass an ID to construct it. Let's now go to the vehicle side of it. Vehicle is an abstract class, and it also will have a size and string of number plate, and it also has a parking space. If it is initially, it will be a null, but when it is parked, then this value will be populated. If it is removed, then it will again be null. And to construct it, we need to pass a size and number plate. After that, it can't be changed. Size and number plate can't be changed, but we can get those values, but we can allocate the parking space by setter of that. And as this is a abstract class, it is being inherited by 3 other classes. Bike, it extends vehicle, and when it is initialized, its size becomes small automatically. So is the condition for car, medium. So is the condition for truck, large. Size is large in here. And let's see what the vehicle class abstract class has. It has the methods to get its size, get the number plate of it, and also the parking space. But we can set the parking space so that we can park it and know in which parking space it is been parked. And also the space allocator has the setter for vehicle, as we had discussed it previously. Now let's go towards the parking lot class. When a vehicle needs to be parked, this method is hit by passing the vehicle, which is constructed by the main method, and it will go and check for each and every floors. And initially, if the number of spaces available is 0, then it will skip it. It won't check for the floors if any of the parking space for that floor is empty or not, because this number of spaces available, it has instructed that none of these parking spaces is available. If not, then we'll go inside this and we will try to hit this park vehicle method of floor. And when the park variable is found, the parking space is written by that variable, this method. And if the parking space is not null, then we will allocate that space, and we will return that parking space. If none of the parking spaces are found, then we will console this, we will print out this message and return null. And let's go inside this park vehicle method of floor. When a vehicle is passed inside this from the parking lot, it will go and check for each parking spaces and check if its size, the parking space, this, if the vehicle size is equals to the parking space size. If it is, then that vehicle can be allocated to that parking space. And we also need to check for other condition, that is the parking space, its space allocator. If it does not have any vehicle, then it is eligible for the other vehicle, the incoming vehicle, to park. If it is not null, then a vehicle is already parked inside of it. If these two conditions are met, then we will go inside the parking space allocator and allocate the vehicle, passed vehicle, inside the property of space allocator. And we will also initialize the start time by instant. This function is called, this function will let us know the current time, and the vehicle also needs to set the parking space, and we will decrease the number of spaces available, this variable of floor, and we will return the parking space. If this condition is not met, then this floor will return null and another floor will be checked. Hope it makes sense. When a user needs to remove their vehicle, then the floor ID and parking space ID is provided, and it will go and get that floor from that floor ID. And in the floor with the specified floor ID, we will call the remove vehicle by passing the parking space ID. And let's go inside of it. And we are also again going to check for the parking space with this parking space ID, and if it is found, then we will print out the starting time and calculate the price if necessary. And we are going to remove the parking space from the vehicle, and also remove the vehicle from the parking space allocator. And we are going to increase the number of spaces available because our vehicle is removed, and we are going to return out from this function by returning this vehicle. If this operation could not be performed, then we are going to return null, and parking lot also is going to return null by printing out parking space was not found. Hope this code review was helpful to you guys. The GitHub link is provided in the description section. Thank you guys, have a nice day.